An introduction to partial fraction decomposition with distinct linear factors. What are we going to do here? Well, you want to decompose the fraction so that you get unlike denominators. It's like completely doing things backwards. You remember how your teachers told you, how do you add fractions? You find common denominators. Well, now we start with a denominator and we want to break it up into fractions with uncommon denominators. And there's actually a procedure for this as long as you have some factors that we can work with. For this particular example, we're going to work with distinct linear factors. So let's highlight those distinct linear factors. X is linear because it has an exponent of 1. It can't have square root symbols. It can't have exponent of 2 or 3 or 5. So x is linear, and that's a linear factor. And x minus 1 is linear, and that's a linear factor as well. The way we break up a fraction that has a denominator composed of linear factors, we will actually break it up with a numerator over one linear factor plus a separate numerator over another linear factor. And that is our goal. Our goal is to actually separate this. I'm going to start over here. I don't like what I did. It's not very clean. So I'm going to erase this. And I'm going to put this off to the side. Often, when you perform partial fraction decomposition, you want to leave yourself lots of room on your paper. You might want to use lots of paper as well. And typically, to stay organized, do your work off to the side and then bring it back in to your the body of your mathematical essay, right? Bring your work off to the side and then write your work neatly when we get it back over here. So 5 over x times x minus 1, our goal is to break this up into a over x plus b over x minus 1. Notice we have an equation on this side. So that's another reason why I wrote this off to the side. However, the problem really says manipulate this expression. Over here, we're going to use an equation, but in reality, you're just going to manipulate this expression. All right. So how do we solve an equation like this? Well, we use Fractionbusters. So let's multiply both sides by the lowest common multiple, and that is x times x minus 1. The lowest common multiple of all the denominators is actually just x times x minus 1. And we're going to do this same thing over here. This simplifies to a new equation, 5 times a times x minus 1 plus b times x. I'm going to refer to this equation as triple star because we're going to use this over and over again. Because we have linear factors, we are going to test values to get these missing variables. And the missing variables are actually a and b. Now this equation is true for all x values. So we're going to test certain x values to get a and b. We're going to test, let's say, x equals 0. If you test x equals 0, triple star becomes what? What does triple star equation become? It becomes 5 is equal to negative a. And then we have 0 times b, of course, is 0. So we got a. A is equal to negative 5. Now how do we get b? Well, we're going to test triple star again. We're going to test triple star this time by letting x to be 1. And if you let x be 1, we get 5 is equal to 0 times a plus b. So we're just left with b. And so we get b equals 5. Now we take this work that you put off to the side and you go back and rewrite your expression. Your expression now becomes negative 5 over x plus 5 over x minus 1. And that is in fact your final answer, but your work is done off to the side. So this is your final answer, but your work is necessary. So make sure you're able to show all this work.